Hi there, welcome to the online school. It's yet another series for exam revision. In this series, we'll be talking about algebra. Algebra is a very important part of mathematics that every student needs to know. We're going to start right from the basics, simplifying, evaluating until we reach quadratics. Various questions from past papers have been collected, and you can see the various parts of which papers have been collected. So I'll be focusing much more on the questions because we have quite a lot. The first one here is asking us to simplify. Whenever we want to simplify, key things you should remember are to collect like terms. So we have A and B in this algebraic expression. So first we will write this expression as it is because we have some brackets there. We get rid of the brackets. What happens here is we have a 1 in front of this bracket that we multiply throughout. Plus 1 multiplied by B plus 1 multiplied by minus A. Later you see how this changes if we have a number here. So let's collect all the terms that have A. We have 2A, we have minus A, and for the B's we have plus B and minus 2B. With this written, we can easily do the arithmetic. What happens when we're working with algebraic terms is if they have the same term or the same variable, we have A and A here, we just focus on the numbers. So 2A minus A is just the same as 2 minus 1, but it will be 1A. However, when we're writing algebraic terms, just like you can see here, we don't put a 1. So we'll just write it as A. We do the same here, B minus 2B, this gives us minus 1, 1 minus 2 gives us minus 1, so our final is minus B. So this here is our final answer. You can see they are very simple questions that are sometimes asked. Next, let's try simplifying this. The procedure is still the same, however we have a bit more variables. We have AB there. You can see directly when solving, the first thing I do is collect my like terms. 2AB minus 7AB. I check if AB squared is present. Yeah, it's present on two parts, and it's always a good idea to start with the positive numbers. Doesn't matter much, but yeah, it's always a good idea. So we have minus AB squared, it's supposed to be A, B squared, and then we have our A squared B term. Then next we do the arithmetic. 2 minus 7 minus 5AB, 5 minus 1, that's 4, so that's 4AB squared. Then we put our last term there, A squared B. It will be okay for you to leave your answer like this, but it's a good thing to always put your positive answers at the start. So I'll write this like this, and this will be my final answer now. You can see simplifying is not a very difficult question. Next, we also have another one here. You can see we have a 2y. This time you can see we have a negative 3 before the brackets, which means we'll be multiplying negative 3 multiplied by x like that, and negative 3 multiplied by negative 4 minus y. Then we simplify further. We have 2y minus 3x. Minus minus gives us a positive, so we have positive 12 minus y. Working this out, we have 2y minus y minus 3x plus 12. So these here give us a y. We write the 3x there, there's no other x term. So this can be our final answer. Alternatively, you can put the number in front and that will be fine. Let's look at another question here. You can see they are all simple. We're getting ready for the bigger stuff in other parts. we do what we did earlier, 3 multiplied by 4x, and then we also do a 3 multiplied by negative 5, then add our 2. 3 multiplied by 4 is 12, then we multiply the x, which gives us 12x. We do the math there. 3 by negative 5 is negative 15. We add the 2, and our final answer should be 12x minus 13. The next question here is asking us to expand and simplify. So it will be the first time encountering such. There are 2 ways in which you could do it. The best that I recommend is you getting this first element from the first algebraic expression. What we have here is just 2 algebraic expressions multiplied by each other. So you get from the first algebraic expression the first term multiplied by the whole expression that is coming after here. You can see we have 2. The expression coming after is 3a minus 4. Then we do the same, plus 3 multiplied by the second expression. This is the easiest way that most people are taught. After that, we will just do our multiplication like we did for other questions. 2a multiplied by 3a. We start with the numbers, gives us 6. The letters a squared. The numbers here for 2a multiplied by negative 4 will give us negative 8. Then we have our variable. 3 multiplied by 3a, that's 9a. 3 multiplied by negative 4, that's negative 12. Then remember, we were told to simplify. This is the correct answer, but it's just not simplified because we have 2 terms that have a common a. So we can simplify. This is our required solution. The next question asks us to factorize completely. What we will have to do here when we see 4 terms, we will use a method called factorizing by grouping. So we'll treat these as our first group and then these as our second group. Then we are going to attempt to factorize the first group. What is common in 6ax and 4ay? What is common is an a, and apart from the a, we can also see a 2 is common. When you have 2 terms and you're looking for what is common in both, the question you'll be asking yourself is what can go into these 2 numbers? What number, of course. So 2 can go into 6 and 2 can go into 4. So that would be a factor. Then for the variables, just look if that variable is present in both variables. So here you can see we've got a and a. So without talking so much, we can have a 2 and a. Then we open brackets. We look at this term here. We ask ourselves, what can I multiply by 2a so that I have 6a? To get 6, I know I just need to multiply 2 by 3. To get x, I just need to have the x there. I'll do the same for the second one here. In order for me to have negative 4, I need to multiply by negative 2. In order for me to have a y, I'll need to have a y like that. Always check that when you multiply these, they take you back to the first group there. Then we do the same for this other one. We'll get the sign negative, and then we'll check what is common in these 2 terms. 3 and 2, is there any common number that can go into both? What we call a common factor. Actually there is, if you think. If you think of 1 can go into both 3 and 2. So 1 is our number that is going to be a factor. For the variables, b is common in both. So we'll put a b. By virtue of putting this b, it's like we put a 1 in front. Then after that, we'll write our remaining parts here. 3 and x. In this other term, what is remaining? It's a 2 and a y. Notice here, we need to have a positive 2, but we have a negative b here. So to fix that, we put a negative here so that when this negative and this negative multiply by each other, they give us a positive. This is why I said it's very important for you to check. Most of the time when you do your factorizing correctly, most of the expressions that you'll be given are going to have the same parts in the brackets. I hope you noticed that. We have 3x minus 2y and 3x minus 2y. This is what is going to allow us to factorize completely. Now, in the next step, what we'll do is we'll write that part which is common, 3x minus 2y. It's common in both, and then write the remaining part. If we factor out from this whole expression, we put 3x minus 2y in brackets. What will be left with here is 2a and minus b. So this is now our completion of factorizing. Let's do a similar thing for this question here. You notice we have AB. In here we have xy. In the third term we have ay. In this other one we have bx. You can see this time it's a matter of you choosing right. We cannot get these two here and attempt to start our factorizing with this group. So the first thing we have to do in this question is rewrite. We have 2ab, then I get 2ay. You can see these now have a common variable. Then I have my xy and my bx. So with this now I can perform factorization by grouping. So the first two are going to be my first group, the second two are going to be my second group. With that, I'm going to look for common factors. I'll start with the numbers. The common number here, or a number that can go into both the first two numbers, is 2. Then we look for a letter that's common in both the first two numbers, it's a. After that, we check. We have 2a. What can we multiply by 2a to have 2ab? We need to multiply by b. We do the same for the second term. What can we multiply by this 2a to have negative 2ay? First, we treat the sign there. It should be negative, and then we put our variable. We do the same for this other one. We will start with a negative this time because of how we're going to go about the question. But let's say you start with a positive. Most people will write a positive intuitively. If you just write a positive here, you won't get the wrong answer. You just have to do a bit more. So we have plus. What's common here is a 1 and the variable x. So we have x, then y remains, and we have b. So you think to yourself, you are done with the factorizing when you look at the answer like this. This is why I earlier said it's better that you put a minus sign before the x so that what you have in the brackets can look identically the same. But now, if you look at the first bracket here, we have the first parenthesis, we have b minus y. In the second parenthesis, we have y minus b. What we need to do to any of these two is just manipulation. We can multiply by negative on any of these two, and the answer will still be correct. Since we started with b minus y here, let's try to make the second parenthesis be also b minus y. That won't be difficult. What we have to do is factorize a negative. Instead of putting positive x here, we're going to put negative x. So to make this statement correct while there's still negative x here, what we're supposed to ask ourselves is, what can I multiply negative x by to have positive xy? It should be a negative, so that negative can give us positive and then a y. Next, we do the same. What can I do to this negative x so that I have negative bx? I need to multiply by plus b or positive b. Then here it's just a matter of you rearranging these terms and you have what is in the first parenthesis. So I have 2a b minus y minus x b minus y, and then we perform our final step, which is writing the common things here and then writing what remains. 2a minus x is what will remain, and we have solved this, actually factorized. It's very important that we use the correct words in mathematics. Solving is finding the value of a variable. Factorizing is doing what we have done, putting some things in brackets such that if you multiply, you get back to the simplified version. Let's do this last question on factorizing. At first glance, this question looks like it's the same one we were doing, but actually it is not. We are doing a different one, but the procedure is going to be the same. In this case, you can see we have the first two having a common factor, so we go ahead with the factorization process. We find the numerical common factor here, the number, so we have a 2 that can go into both these first two terms. Also, we shouldn't forget the variable. We have x, then we go to the next term. What can we multiply by 2a to have 4a or y? We need to multiply by 2y. Next, we put a minus, then we find which number can go into 3 and 6. 3 can go into both those two numbers, and then we look at the variable which is in both. It's b. After that, we write the remaining part. We will be left with a 2, and then we'll be left with a y also. Next, we'll write what's common in the parentheses here. X plus 2y is common in both parentheses or both brackets. Then we have a 2a which will be left, and a minus 3b. Notice that this working strategy, if you were to multiply or expand this, we had the question that asked us to expand. Remember, we did the reverse. We could get the x and then multiplied by the second algebraic expression. What you have to see here is that you can also do it with the second expression. If we get the 2a and multiply it by the whole lot of the first expression, we get this first part here. If we get the minus 3b here and multiply it by the first expression, we get this part that we had on top. That's a very key thing that you should note about expanding. It's not always that you should start with that first term here and multiply it by the second expression. You could also start from the second expression. The other part of algebra that is very important apart from factorizing, simplifying and expanding is algebraic fractions. Here we've been given a question which is asking us to express this as a single fraction, and a key word that you should always never forget to read its simplest form. You'll see how that will affect our solution. The first thing that we'll do here is perform the subtraction. To start with, I would like you to remember how we do regular addition and subtraction of fractions. Let's say we had 2 over 3 minus 3 over 5. How would we do the mathematics? Well, I'm sure most of you should recall. We first find the lowest common multiple for 3 and 5, a number that 3 and 5 can both go into, that is the smallest. 3 can go into 3 itself, 6, 9, but the only number that 3 can go into that also 5 can go into is 15. How we find that number is by multiplying the 3 and the 5. After we do this, what I want you to notice is when finishing up our answer for the numerator, we get a 2 and then get the denominator from the other fraction. Get this sign that's here, the number that's there, and then get the denominator from the first fraction. So first we multiply the denominators. After we do that, next we multiply the numerator by the denominator of the other fraction, and then we just simplify. This process is also very key when we're dealing with single fractions. It's supposed to be noted that this method here is supposed to be used when our denominators cannot be multiples of one another. For example, if this question was like 2 over 5 minus 3 over 15, of course this can simplify, but if I was supposed to find this, the first thing that I can do is okay, let me put a different number here, like 4. If this is the case, 5 can go into 15, so our lowest common multiple is not going to be 5 multiplied by 15, it's going to be 15. So 5 is a multiple, 15 is a multiple of 5. In this case, you can see the difference in the approach when you have denominators that can go into one another in simpler terms. So let's continue and see how we can answer this question. The first thing, like we said, is multiplying our denominators, x minus 1 multiplied by 1 minus x, and then multiplying the numerator for the first fraction by the denominator of the second fraction, kind of a swap. Next, we just do some algebra that we've encountered, some expanding on the top. So we have a 2 multiplied by 1 minus a 2 multiplied by x, which is 2x, minus 3 multiplied by x, negative 3x. Negative 3 multiplied by negative 1 gives us a positive 3. This is a very important step to take note of. The negatives there give us a positive. It's a common source of error. Now at this point we need to simplify. Remember, they said simplest form. We found the answer, but now we need to express it in simpler terms. The 2 and the 3 will add up to give us a 5. The negative 2x and negative 3x will give us a negative 5x. At the bottom we'll have to expand this. Remember, we encountered the question that was talking about expanding. We expand this so that it's in its simplest form. We have x that is going to be multiplied by 1 minus x. We have negative 1. I always encourage people to put the 1 there so that they don't forget about it. Next, the numerator is okay. We need to just work on the denominator. The denominator is x minus x squared minus 1 minus multiplied by minus will give us a positive. So we have positive x. You can see we are getting to our simplified answer very soon. On top we have 5 minus 5x. At the bottom here we have a negative x squared, we have a negative 1, the x and the x give us a 2. So we could start with the highest power, but in mathematics usually you want to start with the positives. So we'll start with 2x minus x squared minus 1. So this is now in its simplest form. There are no brackets, and that's how you can know that it's in the simplest form. Just for some practice, let's do another question here, which is also very simple. We are required to express what we have here as a single fraction. The procedure is always going to be the same. Don't be intimidated by how questions look. We start the same way. We get the 2x minus 1 the denominator of the first fraction multiplied by the denominator of the second fraction and put it as the denominator like we have. Then we get this numerator 2 multiplied by the denominator of the other fraction, 3x minus 1. We don't forget our sign, 3 multiplied by 2x minus 1. We simplify the numerator. Simplifying here will give us 2 multiplied by 3x, which is 6x. In such cases, it's always a good idea that you write this step fully. For such, we have a plus 2 multiplied by negative 1 minus 3, 2x minus 3 multiplied by minus 1. In the denominator, we could also start the processes of expanding, since we know what's going to happen. So we have a 2x multiplied by 3x minus 1 multiplied by 3x minus 1. You can see we've built up from the basics. We started with questions like this and now we're using that knowledge. The first term in the numerator is going to be 6x. Then we'll have a negative 2, negative 6x again, and we'll have a positive 3. In the denominator, we can see we're going to have a 6x squared minus 2x minus 3x plus a 1. So it's a good thing to check through. 6x here is coming from 2 multiplied by 3 and that x. The negative 2 is coming from 2 multiplied by negative 1. Negative 3 multiplied by 2 is what's giving us the 6 here. And then negative 3 multiplied by negative 1 is what's giving us a positive. You also do the check for the bottom. You make sure the x there has a square, has a negative 3x and a positive. Then from here we write our final solution. Notice the 6x and the negative 6x here are going to cancel out because 6x minus 6x is just 0. Then 3 minus 2 is what we'll be left with. So you could cancel like that, and then we'll have a 1 on the numerator. In our denominator, we're going to have 6x squared minus 5x plus 1. We've encountered what we call a quadratic expression. An algebraic expression that has x squared in it is called a quadratic expression. In other parts, we're going to dive deep into these expressions. They are very helpful in mathematics, and there are some processes that we need to learn, some algebraic methods that can be used to manipulate such expressions. This is the end of part 1. Watch out for part 2 that is going to cover more about algebra.